So good afternoon, everyone. My name is Onnicha Leelastwattanagul. So I'm a PhD student from Nottingham Trent University. So today I'm going to talk about the diversity of Collinsella aerofaciens population in the human gut. So to give you some background of this bacterium, the aerofaciens is a common member of the human gut, which have been found over 80% in the European and the Thai population. And it's able to ferment the carbohydrate and degrade the lipid. Interestingly, about this bacterium, the isolate that come from the same donor have the different carbohydrate ferment profile, and also is able to transform the primary to the secondary bisulfonic acid. And moreover, there is some other study that show the aerofaciens effect on the human health, like the rheumatoid and the obese subject that have higher abundance of the aerofaciens, while another study showed that the healthy people have higher abundance of this microbe than the IBS patient. However, all these studies just based on the 16S metagenomic and the correlation analysis, which we don't know much detail about this aerofaciens because they don't have much genome available on the database, and also it's difficult to culture and no selective medium for this microbe yet. And our study would like to study about the diversity of the aerofaciens in the human gut. So we got our collection from Professor Hoy, 211 isolate. And then we submit to the microphagy, and the first lot that we got back is 157 whole genome plus 14 isolates from our collaborator. And then we check the quality of the genome to make sure that we got a high quality genome before we do the downstream analysis. So 169 genome, that's part of the criteria. We did the ANI analysis, and it showed that the isolate that came from the same donor are clustered together, and some that share over 99% ANI value, which we think might be a same species. And when we compare to the Thai strain of the aerofaciens, we found that less than 95% that share the similarity of the genome, which means our isolates are not aerofaciens. And it's also this data, the previous work, they used the 16S to classify the species level. And that means the 16S gene is not enough to classify at the species level. And then we construct the maximum likelihood tree, which show in this one, you will see that the color from each donor tend to cluster together. And when we look in the pangenome result, only 22% that share the common gene, while the accessory gene is high, like 78%. And then we identify the phage gene, only 9 isolates that have been found, and no MR have been found in all the isolates. That might be because we don't have much information about the aerofaciens. And all the results that I just show you is just a preliminary result. So we just got our last 2 second genome back. Yeah, so we're gonna do reanalyze with the whole collection, 211 isolates, and then do the further analysis to find how and why these aerofaciens are very highly diverse in the human gut. And finally, I would like to thank you, my advisor, Professor Leslie Hoy and Dr. Anne McKinney, who helped me train the microbiology skill and culture and find the medium to culture this bacterium. Thank you.